Graphing linear functions. Our objective is to determine whether a function is linear, as well as graph a linear function given 2 points, a table, an equation, or a point and a slope. Who uses this? Meteorologists can use linear functions to predict when a hurricane will reach land. So let's start with some vocabulary. So, a linear function is a function that can be written in the form f of x equals mx plus b, where x is the independent variable and m and b are real numbers. Its graph is a line, so linear function equals line. Line, linear function. They kind of go hand in hand. Now, slope. Slope is the change in f of x over the change in x, or the change in y over the change in x. You might have heard rise over run. So f of x and y are pretty much the same thing. One is just talking about it in terms of a function in terms of x. Alright, so let's look at y-intercept. The y-coordinate of a point where the line crosses the y-axis. So y-intercept crosses the y-axis. It's just that point. And the x-intercept is the x-coordinate of a point where the line crosses the x-axis. So x-intercept crosses the x-axis, and it's just that point. And slope-intercept form is y equals mx plus b. I threw a little line in here so you wouldn't think that this dash was to refer to this as being a negative. So it's just y equals mx plus b. Alright, let's start by learning to recognize a linear function. So for something to be linear, you have to have a constant change in both x and f of x. So for x, you're going up by 2 each time, so that one's good to go. Now our f of x is changing by positive 3, positive 3, positive 3. So because the change is constant, the data set is linear. So yes, it's linear. Alright, so now let's look at b. X is increasing by 3 each time, but notice f of x, to go from 0 to 1, it's plus 1. From 1 to 3, it's plus 2. From 3 to 6, it's plus 3. Because it's not the same each time, it's not going to be linear. So it is not linear. They have to both be the same. So it's not necessarily, it says plus 2 and that's plus 3. This could be plus 3, this could be plus, it doesn't have to be the same number on the top and the bottom, but each time you're changing it needs to be the same. So it needed to have been like plus 1, plus 1, plus 1. And it's not, so therefore it's not linear. Alright, so now let's look at graphing lines using slope and a point. So A will be on the left-hand side and B will be on the right-hand side. So to graph a line when you're given a slope and a point, you're basically going to start at the point and then just rise and run your slope. So we're going to start at point 1, 1, and then we're going to rise and run our slope. So up 2, over 1, 2, 3. Up 2, over 1, 2, 3. You can even go down 2 and to the left 3. And then we can connect those points with a line. Alright, so we have our line. Take a moment and pause the video and try B. When you return to the video, an answer will be revealed. Okay, so notice how you started at -2, 3, and then you basically did a rise over run for the slope, so you went down 1 over 3, down 1 over 3, or you went up 1 to the left 3. And that's that part. So now let's try graphing using the intercepts. So this is just another way of graphing. I find this to be most beneficial when I'm doing a word problem where the numbers are really large and it might be easier just to have the y-intercept and the x-intercept and then connect them with a line. So to start with, we want to find each intercept. So we can start with the x-intercept. Now, to find the x-intercept, we want a number for x. So if we want a number or a value for x, we're going to substitute 0 in for y. So if we're trying to find the y-intercept, we're going to say that y equals 0 for this. Because when you have an x-intercept, y doesn't exist because it's on the x-axis. Either way you think about it, it still works. So we have 2x minus 3 times 0 equals 12. And then just solve for x. So we're going to divide both sides by 2. Since negative 3 times 0 is 0, it's gone. So we end up with x equals 6. So our x-intercept is 6. And now let's look at our y-intercept. So if for our x-intercept we made y equal to 0, our y-intercept is going to be when x equals 0. Because it's on the y-axis, so there's not going to be a value for x. Alright, so we have 2 times 0 minus 3y equals 12. 2 times 0 is 0, so it's gone. And we're just going to divide both sides by negative 3. Which leaves us with the fact that y equals negative 4. So y is negative 4. And then with that, we plot a line. And there's our line. Alright, so let's keep going. So graphing functions in slope-intercept form. To do this, we need to write each function in slope-intercept form first. Then graph the function. So slope-intercept form, in case you need a little bit of a recall, that is y equals mx plus b. Now when you do this, your m is your slope, and your b is your y-intercept. So essentially, our first step is to get y by itself. So, what's on the same side of the equation as y? This 3x, so let's subtract 3x from both sides, because we want to get it by itself. I hope if these look like x's. Here we go. So we've got y equals negative 3x plus 5. And since our y-intercept is b, our b is 5, because it's the one without the variable. So we're going to have a point at 5 on the y-intercept. And now we're going to rise and run our slope. So a whole number can always be expressed as a fraction by putting it over 1. So now we have rise over run. So we're going to go down 3, 1, 2, 3, and to the right 1. Down 3 and to the right 1. And then draw a line. Alright, so take a moment and pause the video and try B. When you come back, an answer will be revealed. And there we have it. So because we have a fraction that's being multiplied with y, we want to multiply by the reciprocal because it's the same as saying divide by 3 halves. So whatever you do to one side, we must do to the other, and we're doing it to the entirety of the other side. So 2/3 times x is 2/3 x, and negative 3 times 2/3 is negative 2. So we start at negative 2, we rise 2 and run 3, or go down 2 and run to the left 3, and draw in our line. Alright, let's look at vertical and horizontal lines. A vertical line is when x equals some sort of a variable, so some sort of a value. So x equals 2, or x equals 1.5. Either way, all the x values are equivalent to that number. So it's going to be a vertical line. When y equals a number, all the y values are going to equal that number. So because all the y values have to equal that same number, it's going to be a horizontal line. Let's check it out. So determine if each line is vertical or horizontal. So we have x equals negative 3. So we want to draw a line where our x values, or all of our x values, no matter what you pick for y, or what you pick, it's going to be -3. So for x to be -3, for no matter what you pick, it's just going to follow this vertical line. And we can draw that in. I'll try to draw it in here nice and thick so you can see it a little bit better here. There we go. Okay. Now hopefully you guys are using a ruler and making things look at least relatively nice. Okay. Alright, so pause the video and try B. When you return to the video, an answer will be revealed, as well as a nicer line for A. Alright, so we have a nicer line for A, and then for B we have y equals +1, and all of the y values equal 1, so we have a horizontal line. So in this case it is horizontal. And that also ends our lesson on graphing linear functions.